Hello, everybody. My name is Marco Sabatini, and I'm one of the founders of Ticino Softwarecraft meetup. First of all, I want to say thank you to all of you because today we are a lot, and it's amazing. Behind the meetup, there are a group of passionate people who love this work, and these are okay. We work together in lastminute.com, and Last Minute is a company that has the headquarters in Ticino, and this is why the name of the meetup is Ticino Softwarecraft. About 3 years ago, we created the meetup with the purpose of open the discussion also to people that work outside lastminute.com. We started organize physically meetup, but after the advent of COVID-19, we have to reorganize ourselves, and we started to organize also online meetup. Why Softwarecraft? So the software craftsmanship is an approach to software development that emphasize both technical and interaction skills of the software engineers. So for the software engineer who believe that working in software is not enough, we strongly believe in the software craftsmanship manifesto. This is the manifesto, and we focus. We put a lot of focus on the point 3 that is related the create a community of professionals. And this is something that we are trying to do also now with this meetup. Because when we start our project, sometimes we don't know, for example, customer domain, or also we don't know the technologies that we have to use. But some practices, like for example, test strategies, design guided by test, and above all, the experiences can help us a lot to reduce the uncertainty and tackle the project iteration after iteration. So sharing knowledge and knowing the practices from other professionals is very important for us. Basically, software development is a learning process, so we must learn to learn. We are also on social stream. We are on Twitter. We have a blog on DevTO blog, and we are also present on YouTube. Of course, you can find the registration of our meetups. But let's go. Today, I'm very proud to have Valentina, and that will talk about the TDD and clean architecture stuff. So, Valentina, the scene is yours.
Thanks a lot. I'm really happy to be here, and I think it's really great how you've built such a community of really, promoting software craftsmanship. So, really happy to be here. Let me know if you can see my screen.
Yeah.
Okay, great. So the topic for today is test-driven development and clean architecture, and we will be focusing on the interplay between use case-driven design and domain-driven design. So short overview about myself. I'm a technical coach and I help development teams to adopt test-driven development and clean architecture so that they can increase quality and accelerate delivery. I also write articles about test-driven development and clean architecture, so feel free to connect or follow me on LinkedIn, GitHub, and Twitter. Now, for this presentation, we will firstly be looking at an overview of what is clean architecture and where use cases and the domain fit in. Then we will proceed to unit testing. So writing unit tests which target the application core and looking at the topic, should we be unit testing use cases? Should we be unit testing the domain? What are the trade-offs in those choices? After that, we will look at integration testing, the adapters, so focusing on integration testing for infrastructure and presentation, because of course, I mean, unit testing is an important and big part, but we also need integration tests as well. We will then look at test quality and how we can evaluate test quality with mutation testing. And finally, there will also be a code demo of the banking kata with Java and .NET. So it's had quite a number of improvements since last time, including expansion of both the unit test examples and the addition of integration tests as well. So for clean architecture, let's firstly start off with hexagonal architecture. So hexagonal architecture, it has the application core. That's the main hexagon, and that's the heart of our system. On the left-hand side, we have these entry points to the hexagon. Those are the behaviors of our system. So those are the use cases. On the right-hand side, we have the server-side API. So that's the interface to the external world, because our application core, it doesn't just exist, you know, in its own world, but it needs to integrate with the external world. So, for example, it needs to integrate with the database, with the file system, with external services. Now, important thing, we don't want our application core to be coupled to the external world, and this is why we have interfaces here. Okay, we've now basically covered the application core and the API of the application core, which consists of the user-side API and the server-side API. And the important thing I want to point out here is the word API does not mean REST API. It simply means the publicly accessible entry points to the hexagon. And inside the hexagon, we have the domain, which could be implemented, for example, with domain-driven design. Okay, looking outwards, we have on the left-hand side these users. So they are somehow using UI application, or these could be external systems which are here interacting with our REST API. So basically, this is the presentation layer, which could be the REST API, the UI, whatever. But we also have any automated scripts, automated tests. Now notice here that the UI or the REST API or the tests, they are all targeting the user-side API, the use cases. On the right-hand side, we can see that in the external world, we have databases, we have file system, we have external services, and we have these server-side adapters, which are basically enable us to integrate to the database or integrate to the file system. So to summarize, the left-hand side is the user side, the right-hand side is the server side, and we have the user-side API, user-side adapters, and server-side API, and server-side adapters. And that's just the notation of everything I explained here. So I highly recommend to everyone, like, going deeper into hexagonal architecture, that really is the foundational essence. Then when we look at clean architecture is basically Uncle Bob took, hexagonal architecture, onion architecture, screaming architecture, and sort of combined it all into one. Here I did the visual mapping of how clean architecture is essentially equivalent to hexagonal architecture. Now, the key contribution that comes in clean architecture is that here Uncle Bob explicitly specifies that the user-side API or user-side ports is composed of use cases, because there's two possibilities. It could have been application services like order service, customer service, or it could be use cases like create order use case, submit order use case. So he specifies that more explicitly. The other aspect is in clean architecture, they just have, the word application core or domain, but not really going deeper into how do you implement the domain at all. But here Uncle Bob specifies that the domain has entities. So these are domain entities. This is really important because these use cases, they are essentially a good representation of how we take requirements, convert requirements into use cases, and these become the API to our application core, which is a powerful concept. Let's look at the impact that this has on unit testing. So we have the hexagon, and we have these the user-side API ports. We have the server-side API ports. Our unit tests can interact with the hexagon just through the user-side API, so targeting the use cases. And here we can have test doubles which simulate the external world. The great thing about here is that we can test the logic for a whole use case through our unit test. So our unit test is essentially an acceptance test of behavior. And key thing here is that since the unit tests are coupled, they are coupled to the API of the hexagon, not to the implementation of the hexagon. So they are coupled to the behavior of the hexagon and not to the structure inside the hexagon. We will again touch a bit more on revisit this topic regarding behavior and structure. Now we go on to unit testing. So unit testing the application core, the hexagon. Unit testing the use cases and the domain. First of all, what are use cases? So here we have the customer. We have a system, a banking system. We look at what are the needs of the customer. Open an account, withdraw funds, deposit funds, etc. And the system needs to provide those use cases. So use cases are essentially modeling the interactions between users and the system with the intent to help the user satisfy their goals. But up to now, did we mention which programming language this will be in? Did we mention which databases will be used? Did we mention, are we going to have object-oriented programming or functional programming or procedural programming? Well, we didn't. All of that is actually an implementation detail. So this is really important thing. Use case driven development is about thinking about the user, the system. So thinking about that interface that the system provides, and what's inside the system, well, that's an implementation detail. We can get to it later. when we're writing unit tests which are targeting use cases, we have the positive flow and the negative flow. So first of all, the positive flow. In our arrange step, we need to set up firstly the system state. So setting up the collaborators. Let's say this use case is the withdraw funds use case, and the withdraw funds use case, the positive scenario requires that a bank account already exists. So here we would set up the bank account repository. We would actually add a bank account to the bank account repository. It's also useful to use setup test helpers here to reduce amount of boilerplate code, and we will see that as well later during the code demo, how that looks like. Okay, so we've set up the system state. We've added our bank repository now has a bank account. We have a request. So the use case is, for this use case, it would be withdraw funds request for account number ABC1001, and we want to withdraw the amount 200 euros. And we have the expected response. So if we want to withdraw the amount 200 euros, but here we've already set up that the bank account has 500 euros, then our expected response is that the remaining balance is 300 euros. So we set up basically the system state, the request, and the expected response act means we have to invoke the use case. So we have this request, which we set up already. We execute the use case. So we say use case, handle this request or execute.
Hi, Valentina.
Yes?
Sorry to interrupt. Are you sharing which number of slide? Because we are seeing the number 9.
Okay, I'm sharing slide number 10.
Indeed, all the people. So we are seeing still the number 9. So
okay, let's see.
Okay, if we can, maybe we can try to reshare again.
Yes, maybe I should stop sharing and then share again.
Yeah, we can try that.
Let's see. Okay.
The beauty of the live,
Yes. So I will do share screen and selecting this tab again. Let me know if you can see slide 10, or if anyone can type into chat whether you can see slide 10.
Okay, so I can see slide 10. So I think because maybe disabled camera was sharing slides. Okay, so yeah, 10. So someone confirmed it. Okay,
yes.
So sorry to interrupt you. And
thanks a lot. Yes, so feel free to interrupt. So I mentioned here that we have use cases positive flow, that we've set up the collaborators, set up the request and the expected response. And then we executed the use case to get the actual response. And finally, we can do an assert. So here we want to assert that the actual response equals the expected response. And we can also assert the collaborator state. So in our initial collaborator state, we had set up a bank account with the balance 500 euros. But here, since we did a withdrawal for 200 euros, we here assert that from our repository, we can retrieve a bank account with the balance 200 euros, if I subtracted correctly. And again, so here we can use assertion test helpers to reduce the amount of code. Then we proceed to testing the error flow. Let me know if everyone can see slide 11.
yes.
Okay, great.
Wow,
so for the error flow,
it's working.
Okay, great. For the error flow, it's basically very similar as before. we still set up the system state and the request. But here, instead of expected response, we have the expected exception. So what do we expect that the use case will throw? Then for act, we have the request, we execute the use case, and it will give to us the actual exception. For assertion, we want to assert that our actual exception is equal to the expected exception, and we also assert the system state. Quite often we will assert here that the system did not change because an exception occurred. So in that case, most likely our assertion is that the system is the same as in the initial state. And both of these tests, they are readable as use case requirements, essentially. So testing both of these flows. Now, when we look at use cases and looking at how we implemented, so we had a unit test targeting a certain use case, and then we have to implement something, which I'm showing here with my mouse. Then we have another use case. This one has some dependency on the external world, so it involves the server-side API, and again we have to implement some classes. And look, interesting thing here, some of our implementation for both of these use cases overlaps. One example is if we have the withdraw bank account and the withdraw funds use case and deposit funds use case, they both share some common code during runtime, which is they both use the bank account class. So it's fine to have overlap. Then we need to implement another use case. Again, we need to implement some classes here or functions, anything, and another one. So important thing to re-emphasize here is that our unit tests, they continue to target just the use case here, the user-side API. The tests are just aware of the user-side API, the server-side unaware, but they are actually not aware of all of these shapes inside. So that's all the internal implementation. And this is great because this means that we can do refactoring in a safe way. Let's say we initially, to implement this use case, we implemented these classes, which are like, here, all of this region. But later, maybe we decide to split our classes. So we're changing the internal structure inside the hexagon, but we're not doing anything to the API. So we now have a different shape, a different structure, but our behavior has not changed. Now, the great thing is that since these unit tests are coupled just to the external API and are not coupled to the structure, the implementation of the system, that we can do refactoring. So we can change whatever is in the hexagon, like splitting classes, changing method parameters, and it will not break these unit tests. And that's, I would say, the most joyous part about coupling units to use cases rather than to the implementation of the system. And I just want to illustrate what this means about, for example, changing classes involved in implementation. Here, to implement this use case, okay, maybe we needed one class, to implement. But maybe we realize actually this one class is doing too much. We actually want to split it into 5 classes, or this happens after some, time has passed and we realize, wait, we can do it better. It's better if it's split. the great thing is that since the use case tests are coupled only to the system behavior, we can change this structure, so this shape, or how many classes are involved, or what their methods are. We can change it without breaking the use case. So we can physically in our code, we might implement that all of our behavior is in the use case and that our domain is anemic. So we could have all the behavior inside the withdraw use case and not have, and the bank account class could just be, getters and setters. Or we might decide to do domain-driven design, and whereby we would have rich domain entities. So we have rich behavior in our domain, but we also have application-level behavior in our use case. Or perhaps instead of rich domain entities, maybe we don't want to go the object-oriented way. Maybe we want to go the functional way. So maybe we want to have functions, and that's all fine. The tests, these use case tests, remain stable irrespective of the programming paradigm and irrespective of all the little parts, the structures in our implementation. But the question is, okay, so up to now, it sounded like all unit tests should only target use cases. The question is there ever a need to target the domain model? Now, here I do have two scenarios when I personally discovered that it was not enough to just target use cases, when I needed to go deeper into the domain model, even though, well, that's like the implementation of the system. So it is minimal, but there were scenarios when I saw that it was needed. One example is verification of constructor domain invariance. So here the issue is that for some entities or value objects, the use case might not call their constructor, but instead the constructor is called from the infrastructure layer. And I want to give one example. For our bank account, the bank account has a value object account number. Now, account number is some like randomly generated number, essentially, and we have this value object which encapsulates the randomly generated number. The use case itself never says new account number. Instead, the infrastructure, so we have somewhere the account number generator implementation in the interface in our infrastructure, that one actually calls the new account number constructor. So this means that through our use case test, we have no idea whether we have no way to test the domain invariance for that constructor, because the constructor is never called from the use case, but only from the infrastructure. So this is why in this case, we would have a unit test for account number testing the domain invariance when we for constructing it. There's also another case whereby our use case is not able to call a certain entity or value object constructor with invalid parameters, but it is possible for infrastructure layer to try to instantiate that object with invalid parameters. And an example of that is the bank account. It has some parameters like account number, account holder name, and balance. And these are value objects. When they are constructed through passed through the use case in the code constructs them, so they can't be null. So we can't test here the case of null parameters, but it is possible for infrastructure to pass null values. So this is another case where I would have a specific test which actually targets the bank account constructor with these invalid parameters because I can't test it for the use case. Another also situation is testing complex domain logic. This is the case where we have combinatorial explosion, and this happens if we have a pipeline calculation with many interim steps, and it's too hard to just say, well, this is the request and this is the expected response. And I will give one example. Suppose we want to have some credit scoring application. And the credit scoring application, it might take so many factors, ranging from someone's salary, age, geographical region, or whatever, like other factors. And then each factor has its own calculation logic. It's very hard for us to say, okay, this is the request and this is the expected response when there's like 50 factors added. And in this case, we would want, it would be more appropriate to do the more granular testing. Overall, in my experience, this constituted a minority of tests. So I was able to write most tests targeting use cases, but a minority of tests where I had to target the domain, that's okay. I target the domain, even though, yes, it does mean that I'm actually going inside the hexagon. And yes, I do have this additional coupling, but it is a minority of the overall tests. Okay, now that we've covered unit testing in the previous section, let's go on to integration testing. This is where we now want to go beyond the hexagon and look at the external world. Now, the external world consists of what in clean architecture is called infrastructure, or in Hexagonal, it's server-side adapters. And we also have the presentation, which is the user-side adapters. So infrastructure, this is all the code which actually helps, helps us make queries to the database or communicate with external services, communicate with the file system, communicate with the network, communicate with the system clock. And we have the presentation, which could be REST API controllers, or it could be MVC, or whatever other console application, as just some examples. So integration testing helps us test at the periphery. Now for testing infrastructure, we can have fake infrastructure, which is what we used as the test doubles in our unit tests, and we're also going to have real infrastructure. Now, since fakes actually contain simulation of behavior, we do have to write unit tests against fakes. But if you're not using fakes, if you're using other test doubles, then no tests are necessary. I'm here referring to fakes because I'm using fakes, and some good arguments which were proposed for usage of fakes is in the book Software Engineering at Google. They outline some arguments which I found valid from my experience. We also have integration tests for the real infrastructure. So the adapter for the database, the adapter for communicating with external web services. Here, what we're testing is, did we make some bug in our configuration? So are we using, the proper connection string to the database? And if we're using an ORM, did we correctly set up the annotations for the ORM records? Can we essentially, if we add a bank account to this repository, can we retrieve back the same bank account? And that gives us confirmation that yes, our mappings are correct. Also for these kind of tests, you can either directly instantiate the infrastructure, so with new, like literally create the infrastructure adapters, or you can also use DI containers in case you have a bit more complex infrastructure and it maybe needs some configuration. So I'm actually using dependency injection containers here in these kind of tests, but not in the unit tests. So when we have infrastructure, fake infrastructure, and we want to test it, if we have a fake repository, some typical tests that we want to run against that is, if I add an entity to the repository, I want to verify that I can retrieve it. Or if I try to retrieve an entity with an ID that does not exist in the repository, that I should get like a null. Here, the implementation for fake is typically, for example, an in-memory hash map, which I can use to simulate the repository. Similarly, I can have a fake event bus. So let's say my use case, when it executes, it needs to publish an event. So it maybe needs to publish an event, bank account opened event, or transaction executed event. Here I can have some in-memory list, and then when I execute publish, it would, for example, add the event to the list, and later I can retrieve these events from this fake event bus. Another other parts which are also typically faked is anything with randomness. So if we have a time service, so get me the current time, we should not anywhere in our code directly call the system clock to get the current time, because that causes non-deterministic tests. Instead, we need to have an interface, iTime service. So during our unit tests, we need to basically have test doubles for the time service as well. Here I'm using fakes. When I set up the fake time service, I typically have an in-memory queue. So I actually set up the time series before the use case is executed. And then here we can verify that if we set up a certain time series, that then when we say fake time service .now, that it returns us the next time. Similar principles apply to number generators. So maybe we have like an account number generator, account ID generator. Again, it's non-deterministic. So we need test doubles like fakes, for example, here as well. And again, these need to be tested. So I just want to emphasize here, if you're using fakes, you need tests which accompany the fakes. But if you're not using fakes, maybe you have mocking, like mock repository, mock event bus, then you would not have this. Then we go on to testing the real infrastructure. So the real repository, it could be implemented with some ORM, or maybe with direct SQL queries, with stored procedures, or maybe we have no SQL databases, or perhaps blob storage or file storage. But our test is basically the same as what was shown on the previous slide. So we add an entity to the repository and we verify that we can retrieve it. Similarly, for the real event bus, maybe we have RabbitMQ, maybe we have Kafka or something else. But again, we need to do a basic test. Okay, if we publish an event, to verify that we can consume it. And this gives us confidence that we are correctly communicating with the event bus. Similarly as the test above, it's giving us confidence that we've correctly connected to the database and that we can retrieve data from it. Now for the random service, the random generator services, well, we can say, sorry, not random, I mean non-deterministic. So for the real-time service, this is where we would use the real clock. So we would call the real, system clock.now. Here, the basic verification we can do is when we call the real-time service multiple times, that we're getting, ascending date times. That's like, I guess, a sanity check. And for real number generator implementation, we might have some third-party libraries for generating UUIDs or ULIDs or Snowflake IDs or EBAN for banking, or perhaps we have some custom way of random number generators or random string generators. And here we can do a basic sanity check that when we call the number generator, that yes, it returns to us a non-null number. And if we call this like 3 times, that we're getting different numbers. These are really minimalist and really basic tests. They are testing like basically sanity checks, and they provide us with assurance that we've correctly connected to the third party library or system, and that we're communicating with it. So testing the integration. We also can do integration testing for the REST API. The way that this is done, and I think not that many people are familiar with it, is that we can stub out the user-side API. So we can stub out the hexagon in order to return certain responses, like regular responses, or to throw exceptions, and then we can test how does our REST API respond. So here are certain things, and this is where we use stubbing. So we are stubbing the hexagon by stubbing the user-side API. We may stub it out and say that when we execute a certain use case, that it will return to us a regular response, and then we verify that we get an expected HTTP response. We can stub the use case to say that it will throw a validation exception, and then we can verify that we get the expected HTTP response for the validation error. We can also stub out authorization exception, and again test the corresponding forbidden HTTP status code. We can also test that if our use case that we stub out throwing of some other like general exception, that we will get a 500 error. And this is really great because this means that we can have assurance that our REST API is able to handle like the full scope of behaviors from the hexagon. And just to repeat again, here we're not testing with the real use cases. We are here stubbing out the use cases. We're essentially stubbing out the entire hexagon to do this test. Finally, we come to system testing. We can say if we have typical microservice architecture, we can say each microservice is a system, and we can run a few end-to-end REST API calls to verify that everything is wired up together. We are not going to call like every single REST API method that exists here. We will just test a few critical pathways because we already have previous tests like the REST API integration test, which would have executed each endpoint. So we're not going to repeat that here. Here I mentioned REST API. Maybe you have SOAP, or maybe you have neither REST API nor SOAP. Maybe you just have event consumers here. Whatever, we're essentially here testing the entire system with all the adapters and the hexagon together. We can also do wider testing of the product itself. So our product might be composed of some front end and 10 microservices, and we want to test this whole system at the product level. Here we would run a few, so very minimal number of end-to-end UI tests, typically executing some business critical happy pathways. And of course, the assumption here is that the front end has unit tests, which are doing more detailed testing, so we don't need to do too many of these end-to-end UI tests. And basically with these proportions, if most of your tests are unit tests, and unit tests are really fast running and low maintenance cost, and then you have a very small number of integration tests and even a smaller number of system tests, then you have a really maintainable test suite. The other aspect here is test quality. Is our test suite good enough? And this is what we can discover with mutation testing. That's an automated way to do evaluation of the quality of the test suite, not code coverage. So that's an important point. Code coverage is very limited. It just tells you which percentage of code you executed, but mutation testing helps us discover our coverage of behavior. So if we have behavioral assertions, do they match up with actual behavior? If we do test-driven development properly, and that means like not skipping any of the steps, so it means following strictly red-green refactor, then if we had specified some behavioral assertions in our tests, for each assertion that we have, we need, and we see it failing, we need to implement some code to actually implement this behavior. And this automatically means that our assertions of behavior and the actual behavior, that there's no holes here. But without TDD, it's a different story. So what happens is, for certain things, we have behavioral assertions in the tests, and then we can have assurance that our code that's covering that behavior is working properly. But for any behaviors where we have a behavior in code, but it's not covered by any test behaviors, we have no idea how this is working, whether it's working correctly, whether it's got bugs. And these are these gray circles, they are holes in our test suite, behavioral holes. Even though this could have 100% code coverage, but not 100% mutation score, and that's where the problem is. So just to summarize, these yellow circles, they indicate where the actual behavior matches the asserted behavior in tests, and this is where mutation testing is able to correctly give us, okay, 100%. But these test suite holes means that we have a missing behavioral assertion, and this is detected by mutation testing. So this means you will not get 100% mutation score here. So here you might get 20% mutation score, even though your code coverage could be 100%, because your code is executed but just not being asserted in the tests. And wherever there's a test suite hole, this means that the actual behavior of the code is unspecified. It could have bugs, it could be faulty, and this is where mutation test is the only way, the only automated way to help us discover these holes. These are the tools that you can do for mutation testing. So pit test for Java, and for .NET Stryker. So I highly recommend everyone to try out mutation testing. Important thing is, if you're using test-driven development properly, you will get 100% mutation score, or close to 100. But if you weren't using test-driven development, then you will get a low mutation score. Mutation testing score. Okay. Now we go on to the last part, which is the code demo, where we will show the banking kata in both Java and .NET. So this banking kata illustrates the usage of test-driven development, clean architecture, use case-driven, and domain-driven approaches. It's available, it's open source on GitHub. Feel free to follow me on GitHub if you want to get further updates. Additionally, you're also welcome to contribute if you have any suggestions or new features for these banking katas. So please see the README file for contributions. The goal of these projects is to have a really comprehensive starter example for test-driven development, clean architecture, and all these related topics. So I will now proceed to share my code in 1 minute. Okay, let me know if you can see my screen.
Okay, I think it's visible. I'm gonna use the full screen mode.
Yes, great, thanks for that.
Bigger.
Okay, so I made the font bigger so that hopefully everyone can read it. So with our application core, we have, and that's the hexagon, we have the use cases. When we look at a use case, this is it has a request, response, and a use case. So the request for open account, it has, for example, the first name, last name, balance. Important thing to note is that these requests are just plain DTOs, and these are primitives. They're not value objects, and there's no entities here. So just using the primitive types. Here I could have manually implemented getters and setters, or I use Lombok. So both of these options are fine, whichever one you want to use. Here I'm also implementing command, and this comes from Pipeliner. So this is one addition which I did in this version of the banking kata, because that enables us to use later the command dispatcher pattern. In any case, here what we're saying is we have a request, open account request, and the corresponding response for that request is the open account response. The response is again just a plain DTO with primitive data types. Then we have the use case. Use case, here again the addition is due to Pipeliner. So this one here. It means I implement this command handler interface, and I pass in my request and response. It means I need to implement the handle method, which takes in the request and returns a response. Additionally, my use case can declare any dependencies. All of these dependencies are the server-side API interfaces. So all of those integrations with the external system. So here you can see the bank account repository interface, since we also have non-deterministic services like datetime, service, account number, so number generators as well. Okay, so we declare our dependencies on the server-side API. And then we proceed to implement our use case. Here I mentioned that the request is a plain DTO, so it does not have entities or value objects, none of that kind. But here, since I'm doing domain-driven design internally, I have to convert it into my domain model. So here, I firstly have get account holder name, and this is where from the request, I'm getting the first name and last name, and it constructs for me the account holder name value object. So I have this value object, I have the next value object, then I create the entity. So I have a bank account entity in my domain. Then I call bank account repository to add the bank account to the repository. And notice all of this here, I'm working with my domain. Finally, when I need to exit the use case, I have to return a response, which is the DTO. So this means, well, since here I had a bank account, and here I can return a plain DTO. Here I've decided to return just the account number. And when we look at this means we can already from the folders see what are the use cases, what's the behavior of our system. We don't even have to open up, classes. We can see it right here, and this matches to the requirements page, the use case diagram. Now let's look at our domain. So we have the bank account class, and it's accepting value objects, not primitives. So all of these are value objects. It has some guard clauses because we want to ensure domain invariants are upheld, for example, during construction. Here we're encapsulating some business logic. So we have the withdraw method, we have the deposit method, and we also have some value objects like account holder name, which has the first name and the last name. And additionally, the server-side API, so all of those interfaces to the external world. This is the bank account repository for finding, adding, and updating bank accounts. And we have the also generators. So here, account number generator, and we have the account ID generator. For validation, I'm using guard clauses to reduce the amount of code involved. So here, for example, I have in many places guard against null or white space. And yes, this is just some fancy code to reduce the amount of code. And again, for long, maybe we want guard clauses like we don't want non-positive, or similarly for money, guard against negative or against non-positive. And the other also, okay, and here is also the time service. So here we're not using the system clock, but we're abstracting it away to return now. And that's pretty much for the core. Then I want to move on to the infrastructure. Now, what's new here is that now in this version of the kata, we actually have real implementations, which we didn't have last time. We have, starting with the database, okay, this is your typical JPA entity. Notice that this is now in infrastructure and not core. So core has no knowledge of Spring data. And this is a representation of how something looks like in the database. And I added here the word record. So basically the word bank account is the actual entity, but here record, it's like bank account record, the database representation, which is, I want to repeat again, in the infrastructure only. Here, we're using the Spring CRUD repository. Again, this is, is needed by the ORM. And when I implement now the interface which I need to implement, it's in terms of the domain. The interface is here. And this is that rich, bank account which had the withdraw and deposit methods, and these are value objects. Okay. So then here in my infrastructure, I have to map between my domain and the way that it's represented by Spring Data. So here I have a value object, but Spring Data has no idea about my value object. So then I need to convert it into a primitive, which is, for example, a string. Then here I'm calling the actual JPA repository. I get some data from the JPA repository, but then I have to convert it to my domain bank account. So this is where I convert it to value objects and the domain entity. So this means in infrastructure, all that we're basically doing is connecting to something and converting. We also have the system datetime service. So this is where we implement datetime service, and this time we're using the real system clock. We also have random number generators. Here I decided to use this third-party library, Sulky for ULID generation. Maybe I could have chosen another library. I can freely change this in the future, which library it will not affect my core. Again, I'm just implementing it. This third-party library is returning me a string, but I convert that string into my value object count number. So again, I'm doing conversion here. And similarly also for the random ID generators. I also want to show the fakes. So this is my fake bank account repository. And here for this implementation, I'm using a map. And when someone says add a bank account, I just add it to this in-memory map. Or when someone says find, I am just returning an object from this map. So that's my fake bank account repository. Again, as I mentioned before, fakes is just one type of test double you can use. You could have used stubs or mocks, but I've chosen to use the fakes. And we also have the fake datetime service. And this is where I actually have a helper because I needed a whole heap of generators. This is where I have a queue, and what I'm doing for these, for the datetime service and for the account number generator and account ID generator, because they are all like a non-deterministic, basically, sequence of something. I have a queue, and then I set it up by adding some values, and then later when someone says next, so give me the next account number, give me the next account ID, I'm just pulling it out of the queue. So that's basically a simulation. And the other also part which is new in this version is controllers, the REST API. So I have a bank account controller, and here I have a post mapping, and I have a get mapping. Here, notice that I'm using the request and the response, the same one that I'm using in use cases, and that I basically pass in this request to the pipeline, and that's again using that third-party library which I mentioned last time. And it gives me a response, and then I return it the web-based, okay, some status. Here I have some primitive, but then here, since I don't have a request here, I build a request, I pass it to the pipeline, and I get a response. So my REST API controllers are basically doing nothing or close to nothing. They are just passing requests onto the pipeline, and that pipeline will delegate to the use cases. And even my REST API is now designed in a use case driven way. So this is like task-based REST API design approach, which is much better than having like a database-based one. But that's, I guess, a whole other story. And I also have some configuration here as well. And for my tests, I want to show the use case tests. So, for example, for the open, I will maybe open up the withdraw. I think that one's more interesting. For the withdraw funds use case, I'm firstly using this setup helper. Given that repository already has bank account, you will notice this is readable almost like Gherkin, and it's a short amount of code. So I'm setting up the system state. I set up my request. I execute the use case, verify that it essentially returns successfully here with void response, and I also verify the side effects on my system. And I can also test the various negative scenarios whereby I'm verifying that the expected validation exceptions are thrown. I mentioned before that most of my tests are use case tests, but that there were a few cases when I needed to go down to the actual domain. And this is where I needed to, for example, actually test the bank account constructor, which was whereby I could simulate negative inputs only from this test and from infrastructure, so it was not possible for the use case. And also account ID, constructing the account ID value object. The use case can never construct an invalid one because use case does not construct account ID, only the infrastructure does. So here I'm testing the constructor on behalf of those infrastructure needs. I also mentioned that sometimes if something is too mathematically complex and we want to split up the testing, that we can go deeper than just the use cases. And one example is scoring. So here I have a score calculator test. Here I'm using mocking. And this is where, okay, so I have a certain bank account and I'm here testing my calculation for the score calculator. And here I am essentially setting up my mocks as well. And then I can go deeper and essentially into all of these factors. So yeah, as we can see that here we're using mocks where it was appropriate, and that we can here, for example, calculate the balance factor and some name factor, time factor, and all of these factors are later used by the scoring factor aggregator. Now this is used within this use case. So the actual use case view account, we wanted to return the score, but since it was too complicating to essentially do a typical use case test for the score, here I'm actually mocking the scoring calculator. And I had these lower level, domain level tests, which actually went inside the hexagon because I wanted to verify all those parts in isolation. And I also have the infrastructure tests. So I'm testing the JPA bank account, repository, So if I add a certain bank account, that I can retrieve it, that I can get back the current system time, etc. Okay, I know I went over time, but I will just quickly, a few more minutes, show also the .NET example. So in the .NET example, we have the request, which is a typical DTO, and we have here we're using mediator, so we're implementing, that's why this iRequest, and here we have the iRequest handler, and we take this request, we implement it in terms of the domain, and our domain, I will open up the bank account. It has these guard clauses so that we can, have domain invariance. It has a business logic, like for withdraw and for deposit. We have infrastructure. We have real infrastructure. So, for example, we have this is in entity framework. We're specifying the record from the database. We're configuring it with entity framework. We have a database context. And we want to implement our repository interface, which is in the domain. But here we're implementing it in terms of entity framework. So we do conversions. We convert here from add. We convert our bank account domain entity. We convert it into this record, which is understood by entity framework, and then add it here. So again, it's just conversions. Here for date time, we're returning the system date time, and for generators, here I'm using some library which I chose for generating ULIDs, and similar case for the other one. We also have fakes, so fake bank account repository, whereby I have a dictionary here. So I just, if someone needs to add a bank account, I add it to the dictionary. If someone needs to retrieve it, I read from this dictionary. I also have the web layer, so bank account controller, and this basically, here we have a request, and we send it to the mediator, and that one delegates to the actual use case handler, and then we get the response, and then we return it in the web-based way. So this is where we have a mediator usage. And additionally, for tests, we have use case tests, which I had shown before, but we can also have domain tests. So as I mentioned, for example, testing the invalid construction of a bank account, which was not possible to cause it through the use case test. And we're also testing the fake infrastructure, so fake repository. If I add a certain bank account, that I can retrieve it. For testing infrastructure, since I have entity framework implementation, but I want to implement it correctly, configure it and do all of those mappings. I create some bank account. If I add it to the repository, I want to be able to retrieve the same bank account. That's proof that I'm properly connected to my database. Here for the datetime service, I'm using the real implementation and basically asserting, okay, I'm able to get some value for now. Addition, thanks to Johan, who added, is also Arc unit tests, so testing the architecture, and this helps us test that developers are not doing any dependencies which are not allowed by the architecture. And I also have some system tests whereby I have everything real. So the real REST API, the Hexagon, and the database, and essentially ensuring that works as well. So this is basically a short overview of the GitHub samples, and returning back, I think there's just a few more slides. So sharing my screen again. So feel free to go on GitHub and see these projects. To conclude, use case-driven design help us drive the system through use cases. These use case tests help us test system behavior rather than system structure. Sometimes we still have to write those lower level domain tests if we're not able to reach something through the use case or due to combinatorial explosion. So this means I do use case tests most of the time, but in some rare cases, domain tests. These use case tests, they are all readable as requirement specifications. These use case tests are robust, so this means I can freely refactor. My domain can emerge over time. I can go from anemic to rich domain, and my tests will not break. I can go from object-oriented to functional, and my tests will not break. So the key benefits of doing tests in a primarily use case-driven way are we get higher robustness of tests and lower maintenance costs. So overall, that results in a higher return on investment. So I want to say thank you to everyone for being here up to now, and I know I went quite over time. And feel free to connect on LinkedIn, Twitter, and GitHub, and I'm now open to any questions.
Thank you, Valentina. was a great presentation. I mean, you summarized, I don't know, maybe 12 books
Yes.
in 1 hour, and I don't know, to see all these pieces together, you can jump off, I don't know, 10 years of experience.
Exactly. It did take me 10 years, and it did take me hundreds of books to be able to come to this. So.
Yeah, because those concepts you find, in different places, but then having an overall picture, I think it's quite difficult, because you need to mix them both. So it very, very great work.
Also, the storytelling was great.
Thanks a lot. I appreciate it. And I see that so many people, it's great to have this audience participation as well.
Yeah, we have a lot of questions, so I try to go in order. So let's see. So this, I guess it's the first one. It's basically, hi Valentina, do you inject a separate clock as an infrastructure dependency every time, or only if date or time are significant part of the domain?
Okay, so first of all, I want to say this dependency injection I injected into the use case. I injected into the use cases that need it. So for the open account use case, since it needed to take the current date time, that's why I injected it into that use case. For the other use cases, the withdraw funds and deposit funds, they don't need time. So then there's no injection of that one. So just to summarize, in my domain, I have the interface date time service, and I inject it into whatever use cases are needed. And in absolutely every project I worked on, there was some need for date time. So in every project, I had the date time service, and then the fake implementation and the real implementation. When this works with dependency injection, I mean, the dependency injection controls the lifetime, whether that service is instantiated once and passed to all, or whether it's instantiated every time. So that's dependent on setup of the dependency injection, how many times it's instantiated.
Clear. Then I guess, okay. So one reason to create domain model unit test is where the infrastructure layer uses constructor, which isn't used in the use case. What is an example of this?
Okay. That's a good question. So in my case, we have the account number. So that's the unique number for the account, and that one is generated by the account number generator.
Mhm.
So only the account number generator in infrastructure, it says new account number. Because that generator is creating the account number. The actual use case, it has a dependency on account number generator, and it just says, okay, give me the next account number, but it itself that does not call the constructor. Now, what happens is when we're doing the unit tests and we have a fake, account number generator. Of course, in our fake, we're obviously going to construct it with the valid stuff. But in the real infrastructure, let's say our third-party library maybe has a bug, and maybe sometime when we call next to the third-party library, it returns to us a null. And this should make the account number constructor raise an exception. So this is one example where we can't cause that situation to happen through the use case test, where we had to actually it can only be caused through infrastructure. But since we can't control the third-party library here, we then write a specific test targeting just that constructor to simulate that. So I pretty much found this to occur only for constructors where the construction never occurred in the use case, but occurred from infrastructure.
Okay.
So yeah, the example in the code is account number. So you can whoever is watching this can open up both the Java and the .NET example and see basically the account number unit test due to this reason.
Perfect. Yeah, then we are going to post the GitHub projects in the description of the video, in the comments, so they are easily accessible. So I'll get another question. We have Mirko. Hi, in slide 13, you talked about testing the requirement and change the logic without breaking the tests. In your experience, when do you usually decide to mock the infrastructure ports and when not?
Okay, so first of all, regarding this is a good question. I'm just now going to go back to slide 13, where I was talking about refactoring. And now here we mentioned the word changing the logic. I will do screen sharing very quickly.
Yeah.
Okay, can you see my screen?
Okay, now yes.
Okay. So here, this use case, it has a certain behavior, and I have some classes here in between, which are used to implement that behavior. Now here, I now maybe split some of those classes. So instead of one class, I have 5 classes or something like that. I've changed the structure, but this is refactoring, but I have not changed the behavior. I want to emphasize that here, the logic, the observable logic, whatever it was, calculation logic or conditional logic, the logic is the same, but it's just in code spread differently, located differently. So that's an example of refactoring. So the point is I can refactor. This means changing structure and not changing behavior. So I'm not changing logic. I can do that safely. So doing refactoring safely. Now, in your experience, when do you decide to mock the infrastructure ports and when not? Okay. So those server-side API ports, they are the links to the external world. Now, in order to do a unit test means I need to have a fully controlled test. It needs to run in memory and needs to run fast. This means I can't use the real database. I can't use the real file system. I can't use the real network. This means I have to mock it. well, the word mock, the more generic word, is replacing it by a test double. So I have to use a test double in order to be able to write unit tests. So the answer is, for unit tests, always, which can be contrasted to integration tests. In integration tests, I'm always using the real infrastructure adapter implementations and not the fake.
Perfect. Okay, I'll get another one. Should the input ports use cases in clean architecture also be interfaces?
Excellent. This is a good example where there was sometimes mismatch in terms of the usage of the words. We can use the word use case in a generic sense to talk about the interface, as in saying we have a request, we have a use case, and we have a response. And then in that case, we can say the request and the response are like data inputs which go into that interface. So we can say the word use case is links to the word interface, but then the use case handler, we can say, is the implementation of the use case. But in many cases, so some people in naming, they will say the word handler when they're writing the class. Some people will just suffix it with use case. But essentially here you'll notice on top that I use the command dispatcher pattern. So the pipeline or the mediator. And in that one, I pass in the request, I get a response. I have no access to the use case handlers. So that's actually my that's the interface. So with the command dispatcher, the command dispatcher is the interface which is exposing those use case ports. That's one implementation. There's also alternatives, but this is a whole big topic in itself. So this is a short answer to that question.
Yeah, there are also additional comments to this.
Yeah, I know there's so many comments. This is why I'm trying to answer each one.
Yeah, indeed. Okay, a second question. What of acceptance test? Does your integration test serve as your acceptance test here?
Okay. So the acceptance tests, my unit tests, which are targeting the use cases, are my acceptance tests, because the use cases are what has what's essentially exposing the behavior, and that's what I'm doing acceptance testing of. So we can say unit tests are in-memory fast acceptance tests. We can also have the more traditional, slower running end-to-end tests, which are also testing the behavior, but just with all the real dependencies. They are also acceptance tests, but just end to end. Now, integration tests, they do not serve they just verify that we're correctly integrating with a third-party component, and that's pretty much it. So not for purposes of acceptance testing.
Yeah, then since you are using fakes, and the fakes should behave, let's say, apparently like the real one, then in the acceptance you are actually testing, let's say, the whole use case.
Correct. Yeah, so people, when they say the word acceptance testing, we can say either that the use case unit test is the acceptance test, but we can also say that the use case test with all the real adapters, i.e. calling it from the REST API and with the real database all connected together, that's also acceptance test. But these integration tests, they are just at the boundary. They're just testing the contract. They're not testing the use case. So that's
Yeah.
Okay, next one, I guess, should be this. What is the benefit of using pipeliner? So I guess this was for Java.
Yes, it was. And it's actually based also on the .NET mediator. So this is just one possibility. This was due to the choice of using the command dispatcher pattern. And this is where I basically have the repeated structure. I have request, response, and my use case handler, it always has the same like handle method, and I pass it the request. That's not the only way to do it. I could have not used pipeliner. I could have not used even request objects. I could have had use case and then like 5 parameters. And from my REST API, I would then do new use case handler and pass several, but that just means more code. So I guess we could say more compact code, and I would say better abstraction with using the command dispatcher pattern.
Okay, next is still Angelo. 2 questions.
Angelo.
How come fakes are in source domain?
Okay. So currently, all of my source code is in source main. Later, I may plan to further break it up. And what happens is that the core is there, the infrastructure there currently, and the web is there. Now, those fakes, they are faking the infrastructure. So in the same way that we have real repository implementations, we also have fakes, and since the real ones are also under source main, the fakes are there as well. In the future, I might do further splitting up of the project, so when the real infrastructure gets moved out, then the fakes will also get moved out correspondingly.
Yeah, on my experience, what I see is that when you put the fake in the source, you might have the benefit of saying you can instantiate and start up your application, let's say in local, like a super fast version that is using all the in-memory stuff.
Yes.
So maybe having those in the source code give you this possibility.
Yes. So if you want to do fast development initially, there's no need for you to set up the real database or real connection to some like third-party service where you have to wait for some other team for like 3 weeks to reply to you, like what's the REST API. You just use your fake.
Yeah.
Use that for demos.
Yeah, for me, above all for the third-party service, because of course the database you can I don't know, use a container or something like this, and you can start also in locally your application easily. But with the third-party service having a fake under contract test, it's very useful to start up in local the application basically. Also.
Yes. And also, whoever is interested more can also see the software engineering at Google Book. Like they also distribute their fakes with source code. So this means whoever needs to interact with your module, and for some reason they don't want to use the real implementation but fake, that they have the fake available. So that's yet another reason why fakes go with source as opposed to being with tests, because then you can actually distribute this to other teams.
Interesting.
Interesting.
It's a 7:04. I don't know if we are out of time or should I take...
I think let's try for another 15 minutes. Let's see how much we can get through.
Okay, I'll try.
I see there's so many questions. I'll try to be fast. I'll time myself now, like maximum, I don't know, half a minute per question.
Next one is from Marco, so we might ignore, So Marco said, I like fake. How do we test fake repo have same real repo behavior?
That's an excellent question. So we actually have very similar tests here for the fake and for the real for the repository. The typical tests I do is add an entity to the repository, expect when I retrieve it that I get the same one back. If I try to retrieve one with a non-existent ID, I want to verify that I get null in .NET or optional in Java. I also want to verify that if I retrieve an entity and I update it in memory, like the entity like .withdraw, but I don't update it in the repository, that then the state in the repository is not changed. So I call it like sort of symmetrical tests. Like I add it and then I retrieve it, and that gives me enough assurance that my mapping is correct, because if I accidentally forget a mapping, I will get a null. Like if in the add I forget a mapping, I will get a null when I for a property, for example, when I retrieve it back.
Okay, but
Okay.
okay.
No, go ahead, Marco.
You can go ahead. No,
Okay.
my concern was if something changed in the real implementation, how can I be sure that this behavior is also, I don't know, I need some feedback also from the...
Well, here's the thing. So first of all, our point is that interface is the main thing. So the contract.
Okay.
So then our point is we're not testing the real implementation. We're testing does the real implementation satisfy our contract. So with these CRUD operations, I didn't see any issues regarding the usage of fakes. Like I add and then I retrieve. Do I get back the same thing? And I do the exact same thing to the real database part. Now the part where you might have issues is when you say, oh, but I have a complex query whereby I'm generating a report from the database. But then for those cases, I do not use the repository pattern at all. In that case, that's a completely other CQRS topic, which bypasses the domain and bypasses all of this topic. So yeah, short answer is we're testing the contract currently in terms of the domain.
Okay, so in real life, how do you structure the repositories of the code? Unit test, I assume together with the code, but I would like to confirm. Integration test, fakes, stubs, and so on.
Okay, so in real code, let's say for backend, we would have a microservice. So within the microservice, all of these tests have to go into the same microservice, not in some separate repository. I'm saying that because I have seen some people doing in separate repositories. That's not the right approach. So the unit tests and the integration tests and also the system test for the REST API for that microservice, they have to go along with the microservice code. So they have to be in the same basically repository. So they all go together. I mean, for example, microservice by microservice, or it's all a monolith and then they're all there.
Perfect. Mm-hmm. Then there is a long discussion about Mediator.
Okay,
that's like it or not.
That's a good topic. Now, the great thing about clean architecture is like we don't care. The main point is to use, request response and these use cases. In my previous implementation a few months ago, there was no mediator. I hand constructed it, and I could have by hand from the REST API said new use case.
Yeah.
New withdraw funds use case. I could have done it and passed all the dependencies. So my constructor, instead of taking in mediator, I could have passed in all the 5 server-side API dependencies, and it's a valid approach.
Mm-hmm.
Okay.
So it's not essential. You don't need to use it. You can look at alternatives, or you can even choose to not use any such libraries, but do construction yourself.
Mm-hmm. Okay, then main of the discussion was around that, or maybe that's the next one. Is the builder used only in the test? If so, is it okay to have in the production code, not only in the test code?
Mm-hmm. Yes. Now I also had builders also in real production code, but I realized I didn't show that part. So the build-up pattern, it exists in general. It's not even related to tests. So this means if you have a more complex, for example, aggregate, which has lots of stuff in maybe the constructor, you can construct in the same way how you have repository for aggregate, factory for aggregate. You can have a builder, for example, for the aggregate in the domain, and it works in terms of other entities, value objects, etc. Now for the test, my test builder, the thing it has different, which is not in production code, is default values. So since I don't want to write like new open account and then pass in 5 parameters, valid ones every time, and then have to like change little bit by bit in a test, then my builder reduces that code in the test by having default values. To summarize, you have both builders in production code, and you have builders as helpers in test code. The difference is the ones in the test code, they are used there just pretty much to reduce the amount of boilerplate code, so you have the defaults. And the other important thing is that my builders in the test, they take in only primitives, so I can encapsulate the domain if but that's, I won't go into that. I realized. To summarize, yes, have it in both.
Perfect. Let's take this one. Did it ever happen when you saw that faking an infra dependency is not necessary?
Okay, that's similar to the previous question, and the answer is we always have to have test doubles for unit testing. We have to have test doubles for anything that's on the server side API.
Okay, then you said you implement an in-memory hash map to store and retrieve. Does that mean that you use a use case that mutates something and a use case that retrieves something to verify it's been added?
Okay, so I mentioned an in-memory hash map as a possible implementation for the repository, for the fake repository. The use case has no knowledge of that implementation. So that in-memory hash map is an implementation detail of how to implement a repository. The other way to implement the repository is with Spring Data, with like Hibernate. Those are implementation details. It's in the infrastructure. Use case only has dependency on the interface, and in the interface there's no hash map. Therefore, the use case has no knowledge of the hash map. Now, during the use case, the unit test execution, the use case we're injecting it with fakes. So yes, that hash map is being mutated in a use case which is doing like repository.add.
We have 2 additional questions from the same person. So the way you explain it is what you are always coupling your unit test to an interface. For
yes,
example,
correct. Now, instead of the word always, I would say maybe 99% of cases, except those cases where I can't. But yes, for every use case, I write a unit test targeting the use case. That use case has dependencies on the server-side API. So then we say my test depends on the use case. So it depends on the request and the response, and it depends on those server-side interfaces like repository interface. This means I can freely refactor my domain and nothing will break.
Yeah, because the interface is supposed to be much more stable than the
correct. Correct. It's highly stable. Interfaces should only be changed if our externally visible like behavior of the system is being changed. If the behavior is not being changed, we should not randomly go around unless we're really bored and changing around the interface.
And then wouldn't you say that input validation belongs to the use case?
Wow, validation is a whole other big topic, and here there's multiple answers. I will give just a short answer of the current approach I'm doing. My current approach is that the domain has all the invariants, and I didn't want to do double validation. I could have, but basically my domain, the invariants will cause exception, and it will return an error. You can also do input validation at the entrance to the use case. That's also a valid approach. So but that's a whole big topic in itself. So short answer is yes. What you've suggested here, it's also a possible approach that can be done.
Okay, I'll take probably the last one. Since your use case could encompass many implementation details, how do you keep them small enough so you can continuously integrate your code and keep the TDD flow?
Depends on what it means, the word slow enough. Small enough. I can't control. I have no control over like the size of a use case logically. I mean, the use case comes from the business. So for this like withdraw or deposit, I'm not the one who invented the use case. It came through, for example, discussions with the business analysts. Now, what I do to actually implement this incrementally, because this use case, it could be a really, really long use case, is we split use case into use case slice. Now it's vertical slicing. So this means we have lots of behavior, but then we, how shall I say, can incrementally implement it. And just to give an example, for example, for the withdraw funds, I will firstly do the testing that, given that I have enough funds, when I attempt to withdraw, that it's going to do subtraction. I mean that I get the subtracted results, and that forces me to implement a use case slice of just that behavior, and then that test, and I'm finished with that test. And then I go on to the next test, whereby I say, okay, I don't have sufficient funds, and I try to withdraw, and then that causes me to implement additional behavior. So just to summarize, we can say when you have a use case, you're splitting it's vertical, like slicing the behavior, and then you incrementally the behavior grows. So that's what we're doing actually incrementally. The actual code base of the use case, it might grow big. The use case file could be 100 lines. Maybe it could interact with, I don't know, 10 domain entities. Like I'm not that's beyond control. So there's no smallness there. It's behaviorally I'm doing it incrementally.
Okay, clear. I think it's 7:18.
Yes, I think we've covered. I see, since there are some good points, I think, at the end. Maybe, I think, Michael from Friends, so maybe you can just quickly show, I think, these last three. I think they're good.
The point to be sure about this one, right?
Yeah. Yes, you can just, so that it's recorded. Yeah, so the point is to be sure about what you talk about complete use. It does not take into account controller and secondary adapters. Otherwise, yes, it would be too long to get feedback. I think that's a really good, important point, because we're firstly testing like the use case in memory and those adapters. Or that's another point which needs to be added with integration tests and trivial validations. This is linked to that topic about validation. In the REST API, you can, with those requests, have, how should I say, basic validations about it's something like empty or non-empty or positive. So I think that's another good point. Whereas, and the point about business validation in entity value objects, that's where it's more complex validation, even though here, I guess in this example, I didn't have that much to illustrate about complexity. Okay, and thanks a lot.
So this I think is perfect for closing up.
There's like 1 minute public thank you, because from the moment that I started posting on LinkedIn, I had really great discussions with Michael, and I really like all of his posts. And I also recommend whoever wants to learn more about like doing test-driven development effectively and this whole use case-driven approach, to definitely also follow his articles. So and thanks for joining.
Thank you.
Thank you.
Thanks a lot.
So for all the people connected, we are going to send on Meetups and on the YouTube description all the links for the GitHub repo and all of that. That's it. So thank you a lot.
Thank you, Valentina.
Thank you. Bye.
Bye-bye.
Bye-bye.